Hi everyone, welcome to my new video in my Mathematics Essentials series. So in the last video I explained some useful trigonometric identities involving sine of theta and tried to give you an intuitive geometric understanding as to why they are true. Okay, and so the video did not get too long. I left a geometric explanation of these identities until the next video, which is this one. Okay, so like the previous video, I will indicate by a red star which identity I am explaining. And I'm going to draw my diagrams down here. So I'll draw a unit circle. And then I will draw a Cartesian plane. Try to centerize it, or center it. Okay, so this is the x-axis. This is the y-axis. Okay, now, like the other identities, what I will do is draw a line from the origin to a point on the circumference of the unit circle. So here's our point, okay? And it's going to have some x and y coordinates, which I will just call a and b respectively. Again, remember, cosine of theta, which is the angle we've just defined here between the line that I just drew and the positive x-axis. Okay, cosine of theta is just going to be a, and sine of theta is just going to be b. Now, consider what the cosine of theta is, according to our unit circle definitions. That is just, in this case, going to equal a, all right? But now, let's imagine that I draw another line from the origin of the Cartesian plane to a point on the circumference of the unit circle. Okay, so here's our point. All right. Since everything is symmetrical, we know that this point is just going to have an x-coordinate which is a, because you can see that both of these points share an x value. So here, actually I'll do that in a different color. Here, okay, that point on the x-axis is going to be x equals a. All right, but you can see that their y values would be different. Okay, so this here is y equals b, and this here, okay, is y equals negative b. All right, so that's how we know the coordinates or the components of the coordinates of these points. So that's a and negative b. All right, so the cosine of theta is a, and this angle here is going to be negative theta. Okay, because it's just an angle the same size as theta, but measured and clockwise from the positive x-axis. And you can see that it shares the same x component as this point here. So the cosine of negative theta is going to equal a as well, which means that these must be equal, the cosine of theta and the cosine of negative theta. So that takes care of this one. Let's consider this one. Negative cosine of theta equal to cosine of pi minus theta. Well, the angle pi minus theta is going to be, oops, here, all right? And this angle here, just between the line that I've drawn and the negative axis would be theta. But since this would be an angle of pi radians, going only this far, all right, would just be going theta less than pi radians around the unit circle. So that angle is going to be pi minus theta. That's how big that angle would be. Okay? Yes, that's the identity we are doing. So we know that cosine of theta is equal to A. All right? What would be the components of this point here? Well, since everything is symmetric, it would intersect the y-axis, sorry, the x-axis at negative A. So that there would be the x value negative A. This green blob here on the x-axis. Okay? And its y value would be positive b. Okay, because if we head across horizontally, okay, we would intersect the y-axis at that green point, which we know is negative b. Sorry, positive b. So this is going to have coordinates negative a, positive b. All right. So when we take the cosine of pi minus theta, we are going to get negative a. All right. But now if we multiply both sides by negative 1 to get negative cosine of pi minus theta on the left-hand side, we realize that we're just going to get positive a on the right-hand side. So they're both equal to a. So the cosine of theta must be equal to the negative cosine of pi minus theta. So, oh, well, that wasn't quite it. What I really should have done is not multiplied this one by negative 1 and just left that as positive a and multiplied this one, negative cosine of theta. So multiply cosine of theta by negative 1 to get negative a. All right, and now we see that since they're both equal to negative a, the negative cosine of theta must be equal to the positive cosine of pi minus theta. So now that takes care of this one. All right. Now let's consider this one. I think I can still keep this on the same diagram. So consider this angle, pi plus theta. That would just be going pi radians around the unit circle, but then an extra theta radians past pi. So that would take us here. Okay. To this point. Okay. Now, similar reasoning to the previous identities would tell us what its x and y components would be. Okay. Because we can see where they intercept the x and y axis respectively. So I think that you can see that the coordinates of this would be negative a and negative b. Okay, I might write that somewhere else. Negative a and negative b. Okay, because we are in the quadrant where both x and y are negative. Okay, let me take a quick look at the identity. All right, negative cosine of theta equal to the cosine of pi plus theta. Right, so pi plus theta would be like, well, not like, it would be this angle here. Right, if I started off here and I went all the way around past theta plus pi over 2, okay, past pi minus theta, all the way 2 pi radians, and then an extra theta radians. Okay, so that blue angle that I've indicated would be the angle pi plus theta. Okay, now we know that cosine of theta is equal to a. We also know that the cosine of pi plus theta, if you just look at the diagram, would be negative a. All right, and if we multiplied both sides of this equation by -1, okay, we would have the negative cosine of theta equal to negative a, and since they are both equal to negative a, these must be equal, negative cosine of theta and the cosine of pi plus theta. So, as long as I've remembered which identity I'm explaining, which I have, unlike last time, that takes care of this one. So, we've got one more to explain, and that would be the cosine of theta equal to the cosine of 2 pi minus theta. Okay, well, the angle 2 pi minus theta would just be the angle we would get if we went all the way around the unit circle to 2 pi and then tracked backwards around the unit circle by an angle equal in size to theta, right? But which we would describe as negative theta because it's measured clockwise from the positive x-axis. Okay, so that would be this angle here, which I'm drawing in green. And we would stop here. Okay, so that would be the angle 2 pi minus theta. Okay, just double check the identity. Yep, cos of theta equal to cos of 2 pi minus theta. So that point we already know its coordinates and that it has the same x coordinate as that coordinate point, that the coordinates for that point does. Okay, they're equal. So this should be enough to understand intuitively why the cosine of theta is equal to the cosine of 2 pi minus theta, because this one would give us a and this one would give us a, which you can see from the diagram. So that takes care of this one. So in the previous video, I explained the sine of theta trigonometric identities, and in this one I've explained the cosine of theta trigonometric identities. I didn't prove them, but I wanted to give you a more geometric intuition as to why they are true, rather than beat you over the head with just a bunch of symbols in algebraic proofs of these trigonometric identities, although proofs are important. But it's equally important to have a good geometric understanding. Okay, if you found this video helpful, feel free to give it a like, feel free to share it with some friends, and if you would like a notification when I upload a new one, subscribe to my channel. Until the next video, bye for now.